let's look at infrastructure as a service, and we're going to concentrate on the notion of virtual machines. We've looked at storage, but now let's look at virtual machines. If we look at infrastructure as a service, what this means is that you're going to be provided computing infrastructure, and you're going to provision it, and you're going to manage it, and you're going to do all of this over the internet. So your servers will not, and storage will not be on your laptop or your desktop or anything like that. What you're going to do is that you're going to provision yourself with servers, and you're going to spin up servers, you're going to spin up storage. You've been doing the storage with our look at S3. And you're going to have all of this networked in a data center provided by the cloud provider. And this is the sort of the basic level of what you're getting with the cloud. So we've already looked at the storage part, but this is really the fact that we're just trying to use the cloud as the hardware and the basic software that you need to run that hardware, and everything else you're doing on top of that yourself. So it's just like you have your desktop or your laptop, except now it's in some data center somewhere, wherever out there, and you're connected to it and you manage everything through the internet. So why would people want to use the cloud for infrastructure? Well, it's very, very good for two aspects of development, and that's the actual development itself and the testing. So when you want a certain type of development environment, sometimes it can be very expensive, particularly with respects to time, to set up everything every time you want to test you want to do something on a different development environment. So maybe you're developing a mobile app, and you're doing one on iOS and one on Android, and maybe you want to have different development environments set up. Now you can do them on the same machine, or you can have two machines, or as many machines as you have developers. But the idea of being able to go up, get your development environment, set it up, do what you want to do there, and then get rid of it is very enticing, particularly when almost everything can be set up immediately. So that makes it good for setting up development environments. But the other thing that it will do is it'll allow you to test. And what's great about this is you can test all sorts of different things. So you can test it running in different operating systems, with different other software, with different storage strategies, with different hardware configurations, different amounts of memory, different CPUs, GPUs, all that sort of thing. You can test all of those things, and particularly if you're doing prototyping, this is great because you can get up, you can see the problems you're going to have, and then you can put that back into your development cycle. Obviously, too, this is when we're looking at storage, and we've looked at this already, it's great for being able to store everything, particularly when you don't know how much storage you're going to need. And that would be particularly bad if you're doing everything on your own server and your own desktop, or if you do have a server farm, you're going to have to make sure that you can handle all of those unpredicted demands that come onto the system, either for more CPU power, more storage, and that's going to be very difficult to do on your own and expensive and hard to do immediately. You can do all of this immediately on the cloud because you can bring in other resources. As long as you have the money for it, you can bring in all these other resources. So it really makes it good for doing storage backup and recovery, because you can do this almost instantaneously, and you can actually program it to do that for you, where you don't have to, as a person, or your sysadmins don't have to actually do this. This will actually is programmable, so it will happen when a certain occurrence is caught by the monitoring systems. Website hosting is ubiquitous now. Everybody has to have a website, everybody has to have some sort of web presence, and it's very easy to quickly spin up a website on most cloud platforms. In fact, not only do they provide all the hardware for you to do it, they provide a lot of the application software that you need, and a lot of times they're actually optimizing for the notion of web hosting. And you also get to adjust all of the different network parameters that you might need is to make everybody coming to the website get a good experience. Obviously, this extends to web apps because you want to be able to quickly deploy them and scale them up or down when the demand is there. And because the demand is often not predictable, in fact, almost always not predictable, having the availability of hardware and software resources and storage resources on the cloud means that you can adapt to what's happening with your application with regards to access, demand, and a lot of that can also, you can put in systems to monitor that. They come with that ability to do that as long as you pay for them. And so you can get a lot of information about how people are using your apps and when you have increased demand, and so you can further fine-tune your system. Now, not that you can't do this yourself. Of course you can do this yourself. All the software that they're using is generally available, but what it means is that some parts of the management of this you can give up to their system so that you can increase the computational or storage assets that you need when the demand goes up. So you don't have to be monitoring that. The system is monitoring that. You can program the increase in the capabilities of your system. Now, there's all sorts of other things too that have been ported to the cloud, and this is for things like high performance computing and big data analysis. So with high performance computing, you may need specialized types of CPUs and GPUs, and many of them, once again, as long as you have the resources to pay for this, you can get access to some very substantial computing hardware in the cloud. With big data analysis, you have two things. One, you need the performance power for doing the computation, but you also need storage. And the amounts of storage, depending on how you're gathering your data, is particularly if it's being collected all the time and streaming to your system, you may once again have to adapt to the amount of storage and computation that you need. The other thing that the cloud platforms have started doing is going beyond this and giving you more different application options. So we'll look at that later when we go past looking at infrastructure as a service. But just even for infrastructure as a service, you have access to all sorts of different types of hardware and storage options that you may not have in-house, or that are very expensive or time-consuming to do in-house. Also, because these things are available for you to try out on the cloud, you can actually do more prototyping, more testing of different options in a far more accessible way, because you're not providing all the hardware and software. You're letting the cloud platform do that, and then you can figure out what you need. Now, at the basis of this computational infrastructure that they're giving you is the virtual machine. So they're not actually saying to you, okay, we have a machine, we have a server, maybe it's a blade and a rack, and you can have that. If you want to pay for that, that's a lot of money. But the thing is, what you're going to do is you want to say, I want something that behaves like it's my laptop or a server or an actual computer. But what I'm going to do is I'm not going to really worry about if it actually is the hardware. I can make do with a virtual machine. So a virtual machine it's an image, software image. It behaves like an actual computer. So for the most part, if you're using this, you won't really notice that that's not like your laptop where you have one operating system on one machine. So it will run in a window of the main system, and it gives you the same experience as you would have on the host operating system itself. Now, you may say, come on, it can't be exactly the same. How about performance? And yes, that is an issue. These systems have to be tuned very well and they have to be substantial hardware to be able to give you a similar experience. One that you wouldn't say, oh my God, I know that this is not a machine because of the performance. One good thing about the way virtual machines are set up is they're sandboxed from the rest of the system. So even though you might have like one hardware system running one operating system, and under this you have the virtual machines themselves won't know about each other and they won't be able to affect each other. And so the host computer actually is the one that is coordinating all of this, and the virtual machines themselves, while they're visible to the host operating system, they cannot affect the host operating system. So the host provides, just like the name says, a place for an environment for the virtual machines, but they're sandboxed from each other and from the host. So they're very good for doing all sorts of things. People use virtual machines, not just in the cloud, but people use them all the time on their laptops or their desktops. We use one in the department, VirtualBox. What it does is it gives you the ability to run an operating system that you're not running on your host machine. You can also do experiments where you want to look at malware or viruses, because it's going to be sandboxed. And you can do all sorts of different things that the original operating system and machine weren't really intended to do. And so while you may have to give up a little bit with performance, you get a lot back in the things that you can do. So you can test out beta systems, you can test out systems that you're building, so that even though something might go wrong, it's sandboxed, and that's fine. It crashes, but the machine that it's running on doesn't crash. So you have this ability to run multiple virtual machines simultaneously on the same physical computer. As long as the computer has enough resources, this is going to be a very viable situation. So how do you do this? Well, what you have to have on the server that's going to be running multiple virtual machines is a piece of software called a hypervisor, and the hypervisor will manage all of these. This isn't actually a new idea. Hypervisors have a long history in computer science, so we've had them for decades. They often were used in a little bit different of a way that we use now, but they were actually there to manage the resources of a system. So most of the time you're used to the system where a desktop or a laptop has one operating system, and that's what you see. But you could run one of these hypervisors, and under that run other operating systems that you could see in a window. So I'm sure most of you have had this experience with one of the VMware, VirtualBox, some machines, Windows, the latest versions provide virtualization. Almost all systems now provide some notion of virtualization. And so what the virtual machine has is virtual hardware. So it's not actually directly attached to any of the hardware. That's the host operating system. But the virtual hardware is mapped to the real hardware. So within the virtual machine, it has a mapping for the CPUs, the memory, the hard drives, the network interface, all sorts of other devices. They are mapped to the actual physical real hardware on the machine. They're not directly accessing them, they're going to access them through the hypervisor. So the hypervisor separates out the physical resources from the virtual environments. So the virtual environment needs various resources. The resources come from the actual physical resources that the machine has. The hypervisor is supervising all of this. That's why it's called hypervisor. It's like a supervisor. It sits on top of an operating system, and with some of them, they do actually have some hypervisors that sit directly onto the hardware, so they are sort of like the operating system that you have. And this is on a server where all you're going to do on that server is offer up virtual machines. So the hypervisor will take all the physical resources, and it will ensure that this mapping to the virtual environments can actually be instantiated. And so what happens is that the resources are partitioned so that you have one big physical environment partitioned into many virtual environments. The users will interact with and run what they want to do in the virtual environment on what's called a guest machine. And the virtual machine then basically within the entire system functions like a large data file that the hypervisor is managing. So when the virtual environment's running and the program issues some instruction that needs resources from the physical environment, the hypervisor is going to relay that request to the physical system. And then the system is going to give it back that information, and it's going to do all sorts of caching and all sorts of things that an operating system does so that you can have as much speed as possible and do many things almost what looks like simultaneously as possible. And so because of the efficiency in which it does this, you can get close to native speeds when you're running a hypervisor as when you're running just the basic operating system. And so what we're going to look at in the course is how you can instantiate or ask for a virtual machine from the cloud platform. And this is what it's doing. The cloud platform on the hardware, they're running these sophisticated hypervisor systems that are going to parcel up and divide this virtual space that maps to a physical space so that you can run as if you're running on the native hardware.